So, let's see here. Day 3. The fundamental theorem of calculus, part 2. So, another form of the fundamental theorem. Objective: find the derivative of the definite integral from a fixed lower limit to a variable upper limit. All right. So let f of x equal the integral from 1 to x of t to the 1/2 power dt. Evaluate f of 9. Okay, so f of 9 would be the integral from 1 to 9 of t to the 1/2 dt. So that would give you, add 1 2/3 t to the 3/2 from 1 to 9. Now, plugging in 9, that would give you what? 18. Plugging in 1, that will give you 2/3. So minus 2/3. 18 minus 2/3 is 7 1/3, or 17 1/3, or you could write that as 52 over 3.
Did you subtract the 2/3?
What?
Why did you subtract the 2/3?
Minus,
Oh,
yeah, upper bound minus lower bound. Just often our lower bound's been 0, which has been real nice. All right. Let h of x equal the integral of 2 to x cubed cosine t dt. Do the integration to find the equation for h of x that does not involve the integral sign. So,
You missed it 56.
oh, I did skip straight to 6. Never mind. I'll do number 2. So, sketch the graph of y equals t to the 1/2. Okay. Try to keep the lines a little straighter than that. So, show the graph of the geometrical mean of f of x. Okay. So, now the square root, we know square root of 1 to be 1, square root of 4 to be 2, square root of 9 to be 3. So if I wanted the actual geometrical area from my previous question, that would be this area right here. Number 3. Do the integrating to find equation for f of x that does not involve the integral sign. Okay. So if we left it as the integral of 1 to x of t to the 1/2 dt, that would give you 2/3 t to the 3/2 from 1 to x. And if we plug in x, it just gives you 2/3 x to the 3/2 minus 2/3.
Just plug X in for
This
here.
Yeah. You plug whatever your bounds are, you plug them in for the variable. So in this case, my bound was another variable. Now, the idea here is we're kind of coming up slowly progressing to the second part of the fundamental theorem of calculus, which is if we differentiate this, okay, if we take the derivative of my function, if we do d dx of the integral of 1x t to the 1/2 dt, all right, what would that be? All right. Well, do I already know what the integral of 1 to x of t to the 1/2 dt is? Yeah, that would be taking the derivative of 2/3 x to the 3/2 minus 2/3. What's the derivative of this? Well, remember for this, you bring down the exponent. So what's 3/2 times 2/3? 1. And then you subtract 1, which gives you 1/2. And what's the derivative of a constant? 0. Does this look familiar? It's what we have in here, except for what happened to t. You got replaced with x. So if I take the derivative of an integral, okay, where one of my bounds, my upper bound specifically, is a variable, does that mean I'm just going to swap the variable out? Yeah, pretty much. So we can do this pretty quickly. What is the derivative? What's g prime? If g is equal to the integral of 3 to x of t cubed, what's g prime of x? X cubed. It doesn't matter what the lower bound is. All right. Now, let me ask this in a better way. Why doesn't it matter? Why does it not matter what the lower bound is? Because it's a constant. When we take a derivative of a constant, what happens to it? It goes away. Hey, Caitlin. You go. All right. So this is something that we did not address in the first half of chapter 6. Okay, that was addressed on the AP classroom. Okay, so because they usually do the fundamental theorem of calculus side by side, our notes apparently decided to split them apart for some reason, which is fine. Okay, but yeah, this is the second theorem, second part of the fundamental theorem of calculus. The challenge is what happens if my upper bound is a function itself. Okay, so we're going to do this kind of slowly, like we did questions 1 through 5 or 1 through 4. We're going to do the same concept. We're not going to graph this though. So if I integrate this, what do I get? So what's the integral of cosine? Sine? Now remember, if it's the derivative of cosine, it becomes negative, but it's backwards for integration. So remember, derivatives of trig functions that start with a c will end up being negative. It's backwards for integration, so if it doesn't start with a c, it'll change sides. So, yeah. So sine t from 2 to x cubed. So that would give you what? Sine x cubed minus sine 2. Got the parentheses. All right. Now, if we took the derivative of this, if we did the h prime of x, what would I get? What am I forgetting though?
1 or negative
3x squared? Where'd the 3x squared come from? Yeah, derivative of x cubed, chain rule. Don't forget the chain rule. So you're going to have that cosine x cubed times 3x squared for the chain. And derivative of constant of sine to the 2 is just 0 because that's a constant. So we get 3x squared cosine of x cubed. Now, what happened? Is there a shortcut I can think of that says if I wanted to take the derivative d dx of the integral of 2 to the x cubed of cosine x, or cosine t dt, all right, is there a shortcut I could do for this? So replace t with the function, and then do what? Take the derivative of the bound. Yes. So with that in mind, could I quickly find the derivative of this function? So I'm going to replace t with what? Sine x, so tangent cubed of sine x to the fifth, right, times what?
Cosine.
Cosine x, because the derivative of the bound, derivative of sine x is cosine x.
That's that 5 means under parentheses.
I mean, you could do that if you want. Because it is sine x to the fifth power. And you could also write it as this, sine 5x. Same thing. I don't know why trig functions do that. I don't know why that's okay. Never really looked it up.
It's a -1. It can't be the negative first power. That.
Yeah, that's the only one it doesn't work on.
But if you do a -2, that works because it's.
Yes.
With a -1.
You can't do that with -1.
Can't be a negative power.
Yeah. Yeah.
That's pretty cool.
Yeah, I understand that. All right, so as a result of your work in problems 1 through 8, you should be able to understand the fundamental theorem of calculus and derivative in integral form. Specifically, if g of x is an integral from a to x of ft dt, where a stands for a constant, then g prime of x is just f of x. And let's use this theorem to quickly find the L prime of x here. So that would just be what? L prime of x would be what? 1 over x. You just replace t with x. All right. The only time you have to really worry about it is if you have a function as one of your bounds. Your bound is a function itself. Now, what happens if x is your lower bound? You flip it and make the integral negative. It has to be the upper bound. Why does it have to be the upper bound? I mean, it doesn't have to be, but remember, what do you do with the lower bound? You subtract it. So it's going to become negative eventually. So it's easier to think about it as just make the integral negative and flip the bounds. Okay. And again, what I mean by that is if we had the integral of x1 of 1 over t dt, all right, and we did the integration, we would get, well, the integral of that is what, natural log? So natural log of 1 minus natural log of t. Well, natural log of x, because we would replace it with x. All right. And then we did the derivative. Well, that would just be 0. We'd end up with a negative 1 over x. Okay. So it's just easier to write this or rewrite this as the integral, negative integral from 1 to x of 1 over t dt. And we'd end up with the same result. That is why if you flip it, you have to do a negative because the signs would switch positions. All right. So we have a bunch of practice questions on the next page. All right. So I want you to try these questions. Shouldn't take you long. So try these, and then we'll go over. Yeah, and the next page is the answer key. Right. So, what's the first one? Squared? Yep. Again, on the first few of these, you generally just replace t with x, right? So 1 plus x to the fifth for number 2. Now, for number 3 and 4, because x is in the denominator, we are going to make it negative tangent of x and negative cosine of x squared. All right, because x is in the denominator. Now, for the rest of these, we have some version of chain rule. So here we're going to have 2x times 1 plus x squared cubed, so x to the 6th. All right, and this one's going to be negative 3 sine 3 of 3x. And then here we have the derivative of 1 over x is, okay, natural log of x times the natural log of x, or just the, I kind of write it 2 different ways, right? No, times the natural log of 1 over x, though, sorry. Of, wait, the derivative of 1 over x is not.
It's negative x.
Yeah.
Negative 2.
I'm thinking integral of 1 over x. So that would be negative 1 over x squared times the natural log of 1 over x. Okay. And then here we have positive 8u cosine of 1 minus 4u squared.
It'd be negative.
2 negatives make positive.
Wouldn't. Oh yeah, you're right.
We'll just simplify it a little further. Yeah. Yeah. Because, again, it's negative because it's in the denominator, and then it's already negative because it's negative 4u. So, yeah, there it is. That is it for today's lesson.